Okay, this is lesson 5.4. We're talking about combinations. So, permutations, we're having some keywords we're going to see here at the bottom. Permutation is an arrangement of elements or objects in a specific order. A combination is a selection. So that's the difference. Now, we use the keyword selection with permutation as well. However, it is a specific arrangement of different objects. Combinations don't deal with the order. That's the biggest thing. So order of selection, order is not important. It's not taken into consideration with a combination. However, order is taken into consideration with a permutation. So this is what we say. We say that for a permutation, order matters. And for a combination, order doesn't matter. So for example, in our probability unit, we talked about I'm going to pick 2 cards out of a deck, I'm going to pick a king, and then I'm going to pick a 5. That example right there told you specifically I was picking a king first, then a 5. But if it tells you you're going to pick a king and you're going to pick a 5, if they don't consider the order they're taken into, it doesn't matter the order. So it doesn't matter if it was a king then a 5 or a 5 then a king, okay? Whereas if we were specifically talking about a permutation of that arrangement, then we would have to take both orders into consideration and then add the 2 choices, okay? That's the difference. So let's take a look here. So combination is a selection of objects without repetition. That's super important. There's no repeating here. So without repetition, and order is not important. Now, the only difference from the permutation equation is we also divide by r factorial. So the permutation equation, we're going to notice, looks very similar. The NPR is n factorial over n minus r factorial. The only difference, like I said, is we also divide out the r factorial, okay? And that's considering dividing out possibilities of repeats, because remember, we don't consider repeats with combinations. So it says the enemy r in the formula stand for the total number of objects to choose from the n, and the r is the number of objects being grouped or mixed, okay? The key points for combinations, there's no repetition and order is not important. Again, here's a couple examples. So if it says, picking a team of 3 people from a group of 10, there's nothing specific there talking about a ranking. But if you take a look at the permutation, it says, you're going to pick a president, a vice president, and a water boy from a group of 10. What is the difference between the first 2 examples there? Yes, a permutation is more specific, so it includes the ranking order. Again, it's order specific. So if you've got ranking orders, it's going to be a perm all day long. Okay? Again, choosing 3 desserts from a menu that has 10 items, or listing your 3 favorite desserts. Well, your 3 favorite desserts are very specific. Okay? And again, it's saying in order. So list your favorites in order from a group of 10. So again, ranking order means it has to be a permutation. Okay? It's a rank. So when you go to the calculator, as you know, we find it in the probability. So we get the math button, we go across the top probability, and then now we're going to hit number 3. Okay, before we were using number 2 NPR, now we're using number 3 NCR. Now remember, you always have to put the number in that you want written first. So if you want the number 8 first, you have to hit the number 8, then math, then the arrows, then the numbers. Okay? So I'm going to show you what that looks like with the calculator here. Okay, so we have to click the 8 first. So I'm going to put an 8, then you hit your math button. Now instead of using your right arrow to go all the way across the top, if you just hit the back arrow, it goes to probability right away. And then we just go down to number 3. And now we want 8C3. I'm going to put a 3, and now we get enter. Okay? So we get 56 different choices. So that's how we type it to the calculator. Here's a couple examples. A committee of 4 people is to be selected from a group of 9. How many committees are possible? Does it give me a ranking? Nope, no ranking, no order. So my N number is 9. My R number is 4. So I have 9 to choose from. I have to choose 4 of them. So 9 choose 4 is going to give us, I believe, 36. 126, pardon me. 126. So when we're talking about permutations, when we say it as a word, we would say if this was a 9P4, we would say 9pick4. The P we would say pick, but with the C we say choose. Okay? That's the difference with our words. All right, number 2. How many 3-topping pizzas can be created if there's 7 to choose from? Now, which number is your N? 7, total N. How many are you choosing? 3. 3 is your R. So 7 choose 3. How big is 7 choose 3? 35 it is. You betcha. All right. Now, just like with the fundamental principle and with permutations, we deal with specific items. We're going to deal now again with specific items. So, we have to include parts of items. So, for example, Committee 5 is to be chosen from a group of 12 students. However, you got a dude named John, and he's got to be on that committee. Well, that means you need a committee of 4 plus John. Does that make sense? Because John has to make up number 5 for your committee. So, we have to do John first. So he's 1 choose 1. Let's see. 1C1. 1 choose 1 is John. Okay? I have 1 choice. I have to choose John. Now I have 4 numbers left, but how many kids do I have left to choose from? If I subtract 1 student being John, how many are left? 11. So we're going to times that by 11 choose. Now how many more kids do I need to choose? 4. Good. Now, just like with our permutations, we're going to notice that the N numbers are going to add up to the total N, 1 and 12, or sorry, 1 and 11 add to 12. And then we're going to notice that the R numbers also add up. So they'll add up to our 5 for R, and the N's are going to add up to 12. Okay, the way they should have. Now, if we multiply our totals, because we do have to multiply the totals, we're going to get John times everybody else. It's going to give us 330 selections. So 330. All right. The next one, you got a deck of 52 cards. You need to make a 5-card hand. Yes?
So the way you put that into the calculator is exactly like that.
Yes. Yep. If you wanted to put it all in one step, you would definitely use the brackets. Absolutely, yep. Okay. The next one, deck of 52 cards. You need to make a 5-card hand, but they're giving you specifics. You need to use the Queen of Spades. I'm just going to move this stuff up so I can see. Okay, move up. So I need the Queen of Spades and the 4 of diamonds, and then I need 3 other cards. So I need that times 3 other cards. Now, why do I need 3 other cards? Because I need a 5-card hand. So, our N number should total 52. Our R number should total 5. And we add up all the N's, and we add up all the R's once we separate them all. So, Queen of Spades. How many Queen of Spades are there in the deck of cards? 1. So this is going to be a 1 choose 1. How many 4 of diamonds are on the deck of cards? 1. So 1 choose 1 again. And then we have 3 other cards. So I've used 2 cards out of 52. How many are left? 50 cards are left, and I need to choose how many? 3. Good. So 1C1, 1C1 times 50C3. And if we look, it's pretty safe to say, I'm just going to retype 1, choose 1, only ever gives you the answer of 1. So whenever you've got 1, choose 1, it's just a 1. So it's 1 times the other answer, 19,600. So it's 19,600 choices for that. Okay, carrying on with our example. So it says combinations from multiple pools. When we are presented with multiple groups, so we have lots of groups, and then we have to multiply the separate cases together. Okay? Now, in the fundamental counting principle, we multiplied our choices, but then we would add each case together. In this case, we're not going to add our cases together, we're going to multiply our cases together. So we have a committee of 3 boys, 5 girls. Needs to be selected from a group of 10 and 11. So this is our N number for boys, our N number for girls, our R number for boys, and our R number for girls. Okay? Now, I need to take boys times girls to give me my total choices. Okay? So, boys, I have 10, I need to choose 3. Timesing by 11 girls, choosing 5 of them. This guy's going to give us 120. This guy's going to give us 462. And that's going to give us a total of 55,440. Please check your work in your calculators. I want to make sure you get the same thing I do. Okay. Next example. So these are the ones where we have multiple pools. So this one says, we're talking about poker. So again, this is a situation where they're going to tell you or show you what a deck of cards looks like and the number of cards you have. Okay? So, poker is a game played from a deck of 52. How many different 5-card poker hands are possible? Well, with no restrictions, 52 cards, we need to choose 5. That's what it would be, 52 choose 5. And it's big. It's almost 3 million. I'm just going to write it right here because it's big. 2,598,960. That's what 52 choose 5 is. So that's how many different 5-card poker hands you can have. Okay? So there's 2.6 million different types of poker hands we can get.
So since casinos use 6 decks of cards now, would it use times 52?
Yep. Absolutely. You times this answer by 6.
Okay.
Yeah. Or you would just do this. You go like this, then go 6. Yep. So you would times it by 6. You are right.
It's so hard.
It's very hard to count cards nowadays. Okay. All diamonds. All right. This, don't forget, you guys. We have N's and R's. We have multiple pools. So we've solved the letter A. How many 5-card hands are possible? B says, what if you use all diamonds? What if they're all diamonds? Well, we got diamonds times the other cards. So, I have 13 diamonds. I'm going to choose all 5. Then, I have 39 cards left. I need to choose none of them. So 39C0, we're seeing here is just 1. Okay, it equals 1. Anything with an R number of 0 equals 1. I was just proving that to you. So basically you're taking 13C5 times 1. Why would I write 13 or 39C0 then? Why do I have to include that? Because the number of card choices has to equal 52. Remember, the N numbers have to add to 52, and the R numbers have to add to 5. So here, if I just use 13C5, I'm missing the rest of my question. Okay? Even though I've chosen all 5 cards, where'd the other 39 cards go? Okay? Even though it gives us a value of 1, it doesn't change our answer. Okay, so the answer for that guy should be 1287. 1287 is what you should have got. 1, 2, 8, 7. Let's take a look. You want 4 black, 1 red. So we want 4 black times 1 red card. So the way we would write this one, how many are black? 26 are black. 26, choose 4 of them. And how many are red? 26. Choose 1 of them. Okay? So 26 choose 4 times 26 choose 1. 6 digits. It's a big one. $388,700. Sounds like you should get. 726C4. C4 is 1495, and then 26C1, it's 26, you got to times them now. So it's 26 times 14950. Okay, that's how we get our answer. All right, now they want us to do 3 kings and 2 queens. So 3 kings. How many kings are in the deck? We have 4 kings. 4 kings in the deck. 4 suits, 4 kings. So 4, choose 3 of them. Times 4 queens, choosing 2 of them. Now, I've used 8 cards out of the deck. How many are left? 44. Now, I don't need to choose any of them, but you still have to include it. 44, choose none. Okay? Because remember, anything C0 gives us a 1. So it's this guy, basically times 1. So, that answer is going to give us 24. When we multiply it all out. Okay, that's for the number 3 here. 3 kings, 2 queens. So we've got our kings here, queens here. Now, what numbers am I looking to add up? You're going to add your N numbers. Your N numbers, remember, have to add to 52 cards. And the R numbers have to add to 5 cards that you're choosing. Okay? Okay, 3 kings. What if I'm using just 3 kings? Well, remember, it's a 5-card hand. So if it's a multiple choice question, and they say, oh, 3 kings, you can't just go 4, choose 3. That's this guy right here, 4, choose 3 kings. If you're forgetting about the other 48 cards in the deck, you can't forget about them. Okay? So, this one, 3 kings, I'm going to draw it over here in greens just so you can see it differently. So, this guy is going to give us 4, choose 3 kings, that's for our kings, times 48 other cards, I need to choose 2 of them. Yep. These, remember, these 2 add to 5, those 2 add to 52. Right? So it's 52 minus 4 is 48. Okay? And then these 2 add to 5. So, we're going to multiply those together. And for 3 kings and 2 other cards to make a 5-card hand, 4704. That's what we should get. Okay, do your work. Make sure you get it on the calculator. Get it properly. All right, 4 aces. 4 aces. Well, how many aces are in the deck? 4 of them. You're going to need all 4. So 4, choose 4. There's your aces. If you want a 5-card hand, so you've got 48, choose 1. Because you need to choose 1 more card. Because you have to have 40 or 52 cards and then 5 cards, right? 48 and 4 and 5, 4 and 1. All right, that's going to give us a total of 48. Okay? 5 cards of the same suit. It didn't tell us what suit. Okay, so that means, since they didn't tell us what suit it is, we're going to have to multiply our answer by what? 4, because there's 4 suits. So it's going to be 4 times 13 in a suit, 13 cards, choose all 5. 39 cards, choosing 0, none. So we're going to get 4 times 13, choose 5, and 39, choose 0. The grand total, 5,148 after you multiply it by 4. You have to multiply it by 4 because it doesn't tell you which suit specific. Okay? Any questions so far? Pretty good with combinations? They're usually easier than permutations, most people think. When you're dealing with cards, cards are 99% of the time always a combination. Okay? All right, let's take a look at the next one. So we're going to deal with at least and at most. We'll just get through a couple examples here. At least and at most. Okay, when solving problems that involve situations where there's a minimum or a maximum. Okay, so this is a minimum or a maximum number of things that you can include. We solve them 2 different ways. So you solve them individually and then add them, or you use the complement to solve, which takes a lot less work. So you have a group of 50 students, half are boys, half are females, girls. So we got 25 boys, 25 girls. How to figure out the number of ways you could pick a group of 10 with at least 2 girls? Well, this is where we're going to go like this. If it's at least 2 girls, that means you can always replace at least with minimum. We need minimum 2 girls. And if it's in a group of 10, that means you could have 2 girls, and it's a group of 10, right? 2 girls, 8 boys. 3 girls, 7 boys. 4 girls, 6 boys. 5 girls, 5 boys. 6 girls, 4 boys. 7 girls, 3 boys. 8 girls, 2 boys. 9 girls, 1 boy. And 10 girls, 0 boys. We have to do every single one of those situations. So there's 9 different situations we have to solve, and then we add them together. Okay? Now, what is the easier way to do it? The easier way to do it, since there's so many of them, is find out what it would be if they only had 0 girls, 1 girl, 0 girls or 1 girl. Because here they're saying minimum 2. Well, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. But it's easier to solve, well, what would it be for 0 girls? What would it be for 1 girl? We add those together, which would be the complement, and we subtract it from the total. Okay? So, again, like I said, you could use all of those, add them together once you're done, or use the complement. I'm going to use the complement here. So, can I erase all my situations? Not quite? Okay, I'll just give you a sec. No. Okay, we are going to pick up with at least and at most tomorrow.